An antenna, or aerial, is an electrical device which converts electric power into radio waves, and vice versa. It is usually used with a radio transmitter or radio receiver. In transmission, a radio transmitter supplies an electric current oscillating at radio frequency to the antenna's terminals, and the antenna radiates the energy from the current as electromagnetic waves. In reception, an antenna intercepts some of the power of an electromagnetic wave in order to produce a tiny voltage at its terminals, that is applied to a receiver to be amplified. Antennas are essential components of all equipment that uses radio. They are used in systems such as radio broadcasting, broadcast television, two-way radio, communications receivers, radar, cell phones, and satellite communications, as well as other devices such as garage door openers, wireless microphones, Bluetooth-enabled devices, wireless computer networks, baby monitors, and RFID tags on merchandise. Typically, an antenna consists of an arrangement of metallic conductors, electrically connected to the receiver or transmitter. An oscillating current of electrons forced through the antenna by a transmitter will create an oscillating magnetic field around the antenna elements, while the charge of the electrons also creates an oscillating electric field along the elements. These time-varying fields radiate away from the antenna into space as a moving transverse electromagnetic field wave. Conversely, during reception, the oscillating electric and magnetic fields of an incoming radio wave exert force on the electrons in the antenna elements, causing them to move back and forth, creating oscillating currents in the antenna. Antennas can be designed to transmit and receive radio waves in all horizontal directions equally, or preferentially in a particular direction. In the latter case, an antenna may also include additional elements as surfaces with no electrical connection to the transmitter or receiver, such as parasitic elements, parabolic reflectors or horns, which serve to direct the radio waves into a beam or other desired radiation pattern. The first antennas were built in 1888 by German physicist Heinrich Hertz in his pioneering experiments to prove the existence of electromagnetic waves predicted by the theory of James Clerk Maxwell. Hertz placed dipole antennas at the focal point of parabolic reflectors for both transmitting and receiving. He published his work in Annalen der Physik und Chemie. Terminology: the words antenna and aerial are used interchangeably. Occasionally the term aerial is used to mean a wire antenna. However, note the important international technical journal, the IEEE Transactions on Antennas and Propagation. In the United Kingdom and other areas where British English is used, the term aerial is sometimes used, although antenna has been universal in professional use for many years. The origin of the word antenna relative to wireless apparatus is attributed to Italian radio pioneer Guglielmo Marconi. In the summer of 1895, Marconi began testing his wireless system outdoors on his father's estate near Bologna and soon began to experiment with long-wire aerials. Marconi discovered that by raising the aerial wire above the ground and connecting the other side of his transmitter to ground, the transmission range was increased. Soon he was able to transmit signals over a hill, a distance of approximately 2.4 kilometers. In Italian, a tent pole is known as l'antenna centrale, and the pole with the wire was simply called l'antenna. Until then, wireless radiating, transmitting and receiving elements were known simply as aerials or terminals. Because of his prominence, Marconi's use of the word antenna spread among wireless researchers, and later antenna to the general public. In common usage, the word antenna may refer broadly to an entire assembly including support structure, enclosure, etc., in addition to the actual functional components. Especially at microwave frequencies, a receiving antenna may include not only the actual electrical antenna but an integrated preamplifier and a mixer. An antenna, in converting radio waves to electrical signals or vice versa, is a form of transducer. Overview. Antennas are required by any radio receiver or transmitter to couple its electrical connection to the electromagnetic field. Radio waves are electromagnetic waves which carry signals through the air at the speed of light with almost no transmission loss. Radio transmitters and receivers are used to convey signals in systems including broadcast radio, television, mobile telephones, Wi-Fi data networks, trunk lines and point-to-point communications links, satellite links. Many remote-controlled devices such as garage door openers and wireless remote sensors, among many others. Radio waves are also used directly for measurements in technologies including radar, GPS, and radio astronomy. In each and every case, the transmitters and receivers involved require antennas, although these are sometimes hidden. According to their applications and technology available, antennas generally fall in one of two categories: omnidirectional or only weakly directional antennas which receive or radiate more or less in all directions. These are employed when the relative position of the other station is unknown or arbitrary. They are also used at lower frequencies where a directional antenna would be too large, or simply to cut costs in applications where a directional antenna isn't required. Directional or beam antennas, which are intended to preferentially radiate or receive in a particular direction, a directional pattern. In common usage, omnidirectional usually refers to all horizontal directions, typically with reduced performance in the direction of the sky of the ground. A directional antenna usually is intended to maximize its coupling to the electromagnetic field in the direction of the other station, or sometimes to cover a particular sector such as a 120 degrees horizontal fan pattern in the case of a panel antenna at a cell site. One example of omnidirectional antennas is the very common vertical antenna, a whip antenna consisting of a metal rod. A dipole antenna is similar but consists of two such conductors extending in opposite directions, with a total length that is often, but not always, a half of a wavelength long. Dipoles are typically oriented horizontally, in which case they are weakly directional. Signals are reasonably well radiated toward or received from all directions with the exception of the direction along the conductor itself. This region is called the antenna blind cone or null. Both the vertical and dipole antennas are simple in construction and relatively inexpensive. The dipole antenna, which is the basis for most antenna designs, is a balanced component, with equal but opposite voltages and currents applied at its two terminals through a balanced transmission line. The vertical antenna, on the other hand, is a monopole antenna. It is typically connected to the inner conductor of a coaxial transmission line. The shield of the transmission line is connected to ground. In this way, the ground plays the role of the second conductor of a dipole, thereby forming a complete circuit. Since monopole antennas rely on a conductive ground, a so-called grounding structure may be employed to provide a better ground contact to the Earth, which itself acts as a ground plane to perform that function regardless of an actual contact with the Earth. Antennas more complex than the dipole or vertical designs are usually intended to increase the directivity and consequently the gain of the antenna. This can be accomplished in many different ways, leading to a plethora of antenna designs. The vast majority of designs are fed with a balanced line and are based on the dipole antenna with additional components which increase its directionality. Antenna gain, in this instance, describes the concentration of radiated power into a particular solid angle of space, as opposed to the spherically uniform radiation of the ideal radiator. The increased power in the desired direction is at the expense of that in the undesired directions. Power is conserved, and there is no net power increase over that delivered from the power source. For instance, a phased array consists of two or more simple antennas which are connected together through an electrical network. This often involves a number of parallel dipole antennas with a certain spacing, depending on the relative phase introduced by the network. The same combination of dipole antennas can operate as a broadside array or as an end-fire array. Antenna arrays may employ any basic antenna type, such as dipole loop or slot antennas. These elements are often identical. However, a log-periodic dipole array consists of a number of dipole elements of different lengths in order to obtain a somewhat directional antenna, having an extremely wide bandwidth. These are frequently used for television reception in fringe areas. The dipole antennas composing it are all considered active elements since they are all electrically connected together. On the other hand, a superficially similar dipole array, the Yagi-Uda antenna, has only one dipole element with an electrical connection. The other so-called parasitic elements interact with the electromagnetic field in order to realize a fairly directional antenna, but one which is limited to a rather narrow bandwidth. The Yagi antenna has similar-looking parasitic dipole elements but which act differently due to the somewhat different lengths. There may be a number of so-called directors in front of the active element in the direction of propagation, and usually a single reflector on the opposite side of the active element. Greater directionality can be obtained using beam-forming techniques such as a parabolic reflector or a horn. Since high directivity in an antenna depends on it being large compared to the wavelength, narrow beams of this type are more easily achieved at UHF and microwave frequencies. At low frequencies, arrays of vertical towers are used to achieve directionality, and they will occupy large areas of land. For reception, a long beverage antenna can have significant directivity. For non-directional portable use, a short vertical antenna, a small loop antenna, works well, with the main design challenge being that of impedance matching. With a vertical antenna, a loading coil at the base of the antenna may be employed to cancel the reactive component of impedance. Small loop antennas are tuned with parallel capacitors for this purpose. An antenna lead-in is the transmission line which connects the antenna to a transmitter or a receiver. The antenna feed may refer to all components connecting the antenna to the transmitter or receiver, such as an impedance matching network in addition to the transmission line. In a so-called aperture antenna, such as a horn or parabolic dish, the feed may also refer to a basic antenna inside the entire system, which could be considered the one active element in that antenna system. A microwave antenna may also be fed directly from a waveguide in place of a transmission line. An antenna counterpoise or ground plane is a structure of conductive material which improves or substitutes for the ground. It may be connected to or insulated from the natural ground. In a monopole antenna, this aids in the function of the natural ground, particularly where variations of the characteristics of the natural ground interfere with its proper function. Such a structure is normally connected to the return connection of an unbalanced transmission line, such as the shield of a coaxial cable. An electromagnetic wave refractor in some aperture antennas is a component which, due to its shape and position, functions to selectively delay or advance portions of the electromagnetic wave front passing through it. The refractor alters the spatial characteristics of the wave on one side relative to the other side. It can, for instance, bring the wave to a focus or alter the wave front in other ways. Generally, in order to maximize the directivity of the antenna system, This is the radio equivalent of an optical lens. An antenna coupling network is a passive network used for impedance matching in between the antenna and the transmitter or receiver. This may be used to improve the standing wave ratio in order to minimize losses in the transmission line and to present the transmitter or receiver with a standard resistive impedance that it expects to see for optimum operation. Reciprocity. It is a fundamental property of antennas that the electrical characteristics of an antenna described in the next section, such as gain, radiation pattern, impedance, bandwidth, resonant frequency and polarization, are the same whether the antenna is transmitting or receiving. For example, the receiving pattern of an antenna when used for reception is identical to the radiation pattern of the antenna when it is driven and functions as a radiator. This is a consequence of the reciprocity theorem of electromagnetics. Therefore, in discussions of antenna properties, no distinction is usually made between receiving and transmitting terminology, and the antenna can be viewed as either transmitting or receiving, whichever is more convenient. A necessary condition for the aforementioned reciprocity property is that the materials in the antenna and transmission medium are linear and reciprocal. Reciprocal means that the material has the same response to an electric current or magnetic field in one direction as it has to the field or current in the opposite direction. Most materials used in antennas meet these conditions, but some microwave antennas use high-tech components such as isolators and circulators, made of non-reciprocal materials such as ferrite. These can be used to give the antenna a different behavior on receiving than it has on transmitting, which can be useful in applications like radar.